So our basic story is going to be that business cycles, ups and downs in the economy, are coming from people not spending enough for recessions or spending, in some sense, too much. So even though there's resources available in a depression to produce more stuff, we don't do it because no one's going to buy that stuff if we do produce it. Okay? Is this going to like to find me? No, it is not. So that's going to be our story. So we're going to need a story about where spending comes from, right? And we're going to do the simplest story that we can do that has something to do with spending and where it comes from. And so for our story, everything is going to be in consumption for our first pass. We're going to be more sophisticated later. We're going to talk about investment a bit. We're going to talk about what government can do in a bit. But for our first pass, we're going to say our story is going to be in consumption. And the story that we're going to have is this consumption function. That is, we're going to think, when we say function, like when we're putting a story into math, what we're trying to do is we're trying to put people's motivations into a structured thing that we can think about logically. So the point of the math here is to force us to think logically. So I could say, if you have more income, you spend more. If you have less income, you spend less. And that indeed is going to be our story. And I don't think anyone would find that horribly controversial or anything. And we could think about that. But we would never be sure that we thought about it completely logically. We would never be sure that we didn't leave something out or put something in that isn't really meant to be there because we have some assumption in the back of our head that we didn't articulate. It's fine that we have an assumption in the back of our head, that we have things that we know about the real world in the back of our head, but we want to be very specific and explicit about what exactly we're assuming here, so that other people don't need the same stuff in the back of their head, and we know where what we get is coming from. Right? And so one of the nice things about putting our story into a mathematical form is that we know exactly what we're putting down, and we know exactly how to manipulate it to think logically about it. And so that's why we use a function. We want to write this in a mathematical form so that we can force ourselves to think logically about it and know exactly what we assumed and what we didn't assume in there. Okay? And if you go back in sort of the history of economics, back in the day, like in the 30s, they would tell these things in a story form. And they would think as logically as they could about them in story form. And a lot of these things worked out great. But a lot of them, when people actually went back, when mathematics became a thing in economics and went back and thought about them, things were left out or logical steps were missed. Okay, so some of them were great and some of them weren't, but you didn't know just telling the story. And so the mathematical formulation of it allows you to know that you're thinking logically about it. And so in economics, in the theory of economics, we have three ways of thinking about things. We have the graphs, we have the story, and we have the math. And we should be able to go back and forth between those three interchangeably. They should all be consistent with each other. And if they're not, that suggests we're missing something or we put something extra in, which is useful to know, and then you have to correct that. So in the end, we want the math, story, and graphs to all be telling the same thing. The three different ways of thinking about the same thing. Okay? The story is nice because that means you're thinking about human beings. In some sense, if your story doesn't sort of match up what humans do, you got a problem there, right? The graphs are nice because it allows you to sort of think abstractly about it, but in a sort of a useful way. You can sort of see what's going on in your story. And the math is nice because it forces you to be completely logical about everything and know exactly what's in there and what's not in there. Okay? So we're going to do the three ways, of course. We're going to do 3 ways. And to put our basic story is people with a lot of income are going to buy more stuff than people with very little income. Okay? It's a very deep story about human motivation, but it seems to capture, I think, something real. Now, you can think it does or you can think it doesn't, but that's the idea. And it's going to be useful to the extent that it's capturing something real, and it's going to be not useful to the extent that it's not. Clearly, it's leaving loads of things out, right? Howard Hughes had a huge income, but he locked himself in a hotel room and he didn't buy anything for years. So, it's not everything of human existence, but it does seem to capture something, at least to me, something real, and that's the idea. Okay, so our consumption function is just going to relate in our case, people's income to how much they spend. Okay? And we're going to focus in particular on after-tax income. That's disposable income. The two things mean the same thing, basically. It's the amount of income that you have actually available to spend. So it's all well and good that you earn 100,000 euros, but if you only get to keep 60,000 of it, 60,000 is what affects your spending. It's going to be our basic story. Okay. So our consumption function is this. It's this top thing. C, that's consumption. Remember, it's the same C that we've had all along. Consumption, the amount that households buy, excluding their purchases of housing. Right? Everything else that they buy is going to depend on this C bar, this little c, and y minus t. So let's go through these things at B. First, we go with the y minus t. Okay, y is GDP. It's income. Because remember, every time you produce something, you got the sandwich, you sell the sandwich, that's income to you, it's expenditure for the other guy. So we're going to go back and forth between these three things. Here, we have income in its y in its aspect of income. Right? There's three ways to think about it. We're thinking about it as income here in this function. Okay? You know, the ancient Greeks, so this is a thing I read, apropos of nothing, but well, a little bit. Ancient Greeks had all these gods, right? And they had, like, Athena was the god of this, she was god of that, she was god of the other thing, and she behaved differently in the stories depending on whether she was using her aspect of the god of war or her god, or whatever the heck she was, right? But each of their gods had multiple aspects. And they told me that, like in classics class way back in the day, and I didn't really get it, but you just sort of think, you know, you're doing 3 jobs. But it wasn't like that at all. It wasn't like Athena was doing 3 jobs. She was 3 sides of her personality or something like that. And so the analogy that I was given, which is very nice, is it's like Barbie. Barbie is always Barbie, right? But sometimes she's an astronaut, sometimes she's a fighter pilot, sometimes she's a deep sea diver, but she's always Barbie. She's got different aspects to her life, but when she's an astronaut, she is fully an astronaut. And when she's a fashion model, she's fully a fashion model, but she is always Barbie, right? So here, we got our 3 aspects to y. Y is income, y is expenditure, and y is the stuff. It's all the same thing. It's all Barbie, but it's 3 different aspects of it. So here, when we wrote down this equation, we used y, which is all 3 of those things, but here we are thinking about it as income, because this is a function that relates people's income to how much they buy. Okay, so here, y is income. Okay? You'll see, we'll switch back and forth, like really quick. So here we have your income, and then you subtract off the amount of taxes that you have to pay, right? And that's how much income you get to keep, your disposable income. Now, you will notice that here we have a very unrealistic form of taxes. This is a form of taxes that just says the government says you owe us 30,000 euros, pay up. In real life, taxes themselves depend on your income, right? If you earn more, you pay more in taxes than if you earn less. Here we're pretending like that's not the case. Again, because we're telling the simplest story that we can, and then we can make it more realistic. So for a homework or an exam question, I could easily change this to make it more realistic, to have your income depend on your taxes depend on your income. We can do that, we'll get exactly the same story. There's slight modifications. But here we keep it as simple as possible. Taxes are just what we call lump sum taxes. They don't depend on anything you do. This is just the amount that you owe. Right? This is the kind of taxes that got Thatcher thrown out of office. So this is not the kind that we're likely to see in the near future. This is just what they call a poll tax in England. Just because you exist and go to the polls, you have to pay the tax. So this is what we got. Okay? Just for simplicity here. Okay, so that's your after-tax income. And then we multiply it by this little c. And this little c is going to be super important to us. It's going to have jargon. It's going to be called the marginal propensity to consume. And I'll get back to this. So this is, if you get a little richer, how much more do you spend? Okay, so we're going to think of this as a fraction. That if you get a little bit richer, you're going to spend some of it. You're going to save some of it. And then it also has this autonomous spending. So that's some amount that you're going to spend even if you have no income. Which sounds goofy, like where does the spending come from? But you can imagine that you're out of work and you got no income whatsoever, you still have savings, you have wealth. Because this is just your income, what you earned this year. But you might be sitting on Smaug's hoard and have 100 million euros in the bank, but have very little income. You're still going to buy stuff, right? Because this is just what you're earning this year. You can, because you're so rich, you can leave that aside. So we're going to think that even if you have no income, there's some amount that you're going to buy. Okay. So we're dividing this basically into two components. We have what's called induced consumption, the consumption that you make because you have current income. Okay? This is income that is induced by your spending that is induced by your income. And we also have autonomous consumption, which does not depend on your income. Now, this is just the way we wrote the function, right? We wrote it as a simple linear thing. We have this C bar plus the induced bit. So right? We didn't have to write it that way. There's lots of ways we could write it. This is the simplest way that we can reasonably write this. It is not the most realistic way that we can write this, right? We made it into a simple linear thing. Life is more complicated than that. But this is our first pass, and so we're going to start there. Okay. So autonomous consumption is going to depend on lots of stuff. It's two things that we're going to be particularly concerned that it depends on is your wealth. If you're really wealthy, right? If you have 100 million euros in the bank, you're going to have very high autonomous consumption. Regardless of your current income, you're still going to live in the penthouse apartment, right? And if you're deep, deep, deep in debt, even if you have a lot of income, you might not spend that much. This might be very low, right, depending on how rich you are. And this is going to be important for us because one of the things that happens in real life is people have, for example, their income tied up in pension funds, their wealth tied up in pension funds. And so if the stock market goes down, all of a sudden people are going to feel poor. Nothing happened to them currently, it's just all on paper. But before they felt like they had a nice retirement coming up, and now the stock market crashes and they feel like they don't. And so this autonomous consumption may vary just whether whether your portfolio looks high or your portfolio looks low. This happens a lot with house prices. They're all talking about maybe we're going to have a house price crash soon. Well, if you have a house price crash, people who have notionally, they live in a little two-bedroom apartment, or a little two-bedroom house, and it's got a leaky roof, but it's worth 200 million euros, and so they feel rich, even though they're living in this little horrible place, right? And so then, when the house prices crash, all of a sudden they don't feel rich anymore. They're living in the same place, nothing in their life has changed really, but they feel poor. And perhaps they were planning on selling that house in their retirement and moving to Ibiza. Right? You don't know. And so now they can't do that because the house price crashed. And so they're going to change their current behavior, not because anything real changed in their life, but because the value of their assets went up and down. And these asset values can go up and down quite a lot, and that changes people's autonomous consumption. So we are going to think that this autonomous consumption actually can vary quite a lot, okay? Because it's capturing all this stuff that isn't in the model, but is actually important about whether people decide to, right? So you can think about this induced consumption is all the consumption that depends on your current income, and the other stuff, all the autonomous consumption, is everything else that matters to you when you're deciding to consume, which is your wealth and whether your grandmother is likely to leave you an estate or all that stuff, right? Also, another thing it depends on very much is whether you're optimistic or pessimistic about the future. Suppose you have a decent job, and you think you're going to be promoted to vice president next year. You're pretty sure about it. Well, then you're not going to worry so much about saving now, right? Because next year is going to be great. You're going to be vice president, and you're going to be able to embezzle tons of money. And so there's no need for you to save now. The embezzlement in the future is coming. So that's great. On the other hand, you have exactly the same job. You're in exactly the same situation. And you all of a sudden realize that all of the current vice presidents have been embezzling like crazy, and this company is just a hollow shell, and it's probably going to go out of business. And so you're going to be out of a job. Okay? Everything's the same in your life, except now you're pessimistic about the future. And you think instead of being rich next year, you're going to be unemployed next year. Okay? Nothing about you, just your perception of the world. And now you're pessimistic about the future. You're going to try to save so that you can eat during the hard times. Right? So if you're pessimistic about the future, autonomous consumption is probably going to be low as you try to save. If you're very optimistic about the future, autonomous consumption will be high because you don't have to worry about tomorrow, because tomorrow is great. Right? And so this is all in our heads. Right? This isn't even anything about what's really going on. This is, do I think the future is going to be brighter, or do I think the future is going to be dark? And that can change autonomous consumption as well. Okay. While we're here, I should mention that everything else will have an autonomous part and an induced part as well. Induced just means something that's dependent on your income in this case. And so you can think about induced investment. Investment that because the economy is doing good, we do more investment. And we can think about autonomous investment that has to do with everything else. Right? We can think about all the different terms as an autonomous bit and an induced bit. But here we've only specified consumption, and so we're going to talk about autonomous consumption, induced consumption. Okay. Okay. Here's going to be something that's going to be very important for us, which is the marginal propensity to consume. This is something, obviously we name it marginal propensity to consume because we want to sound smart. Right? And using big words like marginal and propensity, that makes us sound smart. If we just said what we meant, which was extra tendency to consume, we wouldn't sound so clever. And so we say marginal propensity to consume. It also comes from way back in the day when people talked with flowery language. So the jargon is sitting around from the 1800s, so it's still the same. But marginal propensity to consume is very important. It is how much extra I consume if I get a little richer. So if I find €1 on the ground, how much of that do I spend? Okay. And in general, it could be anything. Right? I could find €1 on the ground and say, aha, I finally have enough for a Lamborghini. I was €1 short. I had been saving and saving, and now I can afford a Lamborghini. And all of a sudden, I find €1, and I spend €500,000. Right? In that case, marginal propensity to consume would be what? 500 million. I found €1, and I spent 500 million. Okay. That's possible. It's also possible that I find this thing, and I realize, I haven't been saving it. It sort of triggers something in me when I say, I'm just going to save everything. And all of a sudden, I find this €, and I cut back my consumption, and marginal propensity to consume is negative. But here we're thinking about it as the economy as a whole. So each individual can do all kinds of goofy things depending on their budget, depending on what their hopes and dreams are and all of that. But here we're thinking about, on average, for the economy as a whole, if everybody found €1, how much more would they spend? Okay? And so in practice, we are going to think this is a fraction that is somewhere between 0 and 1. That when you get a little richer, you spend a little bit more, but you don't spend all of it. You save some of it. Okay? So on average, people will spend some, and they will save some. Okay? That's going to be our assumption. And this is going to turn out to be actually important. Right? And we'll see in the math why this is important. It has to be less than 1 for our story to work. And in principle, there's no reason why it has to be between 0 and 1. On the other hand, we don't tend to worry about this very much because this is something that we can actually go out and try to measure for different economies. And we have never found an economy where it is anywhere approaching 1. So we're OK as a sort of practical matter, but there's no theoretical reason that it has to be between 0 and 1. But we are going to assume that it's between 0 and 1. And this is backed up by tons of empirical evidence. So if you look at an actual economy, if you look at, say, the US, I think it's like 0.96, 0.97, somewhere in there, that if they find an extra €, they spend most of it, all but 3 or 4%. In Europe, it tends to be more like 95%, so 0.95. In Japan, it's even lower. I think it's like 0.87, 0.88, somewhere in there, like almost 90%. So you should be thinking, generally speaking, that it's something like 0.9, 0.95. Okay, that's 0.95 is like a reasonable ballpark figure to be thinking that the marginal propensity to consume is. That is, if people get 100 euros richer, on average, they will spend 95 euros and they will save 5. More or less, on average, for the economy as a whole. Now, it does vary depending on whether we're in good times or bad times. It varies depending on the nature of the society. It varies depending on the social safety net, if you don't, right? And all kinds of things it varies according to. But this is the kind of thing we're talking about, something like 0.95. Okay. Again, in economics, marginal always means extra. You can substitute the word extra always for marginal, and you're good. Mathematically, for those who have taken calculus, it just means the derivative, a little bit extra. How much extra do you get? But here, you get a little bit extra money. How much of that do you spend? Okay. Propensity just means tendency. It's a word that nobody uses anymore, but economists. And so the extra tendency to spend, right, to consume. Okay, so here is our consumption function, graphed out. On the axis, I got disposable income. And if I had no disposable income, C bar is the amount that I would consume. And I think when I stand close to that, this other microphone picks me up. And then as I get more income, I spend more. And the slope is C, that is for each euro that I get in disposable income, my consumption goes up by little c, the marginal propensity to consume. Okay. And this slope is less than 1 because we assumed it so, right? Now you can buy that or not, but that's our story. That when you find some money, you spend some of it, you save some of it, on average, over the whole economy. Okay. That's our consumption function. And we think that it's going to shift up and down, right? That as C bar changes, as the autonomous consumption changes, this thing is going to shift up and down. If I become very optimistic about the future, this thing will shift up. If I become very pessimistic about the future, this thing will shift down. If I think that next year I'm going to be fired, I need to save now, autonomous consumption goes down. If I think that next year I'm going to be promoted, I don't need to save now, this thing goes up. Okay. How realistic is this? Not as bad as you would think. It is certainly not perfect. It is certainly missing a lot of things. But if you just sort of naively plot the data, it's clearly not linear, but it's not linear either. Like it's in the general vicinity. So this is something that we use as a shorthand. The math becomes easy. The calculations become easy. It doesn't really change the story if we make a more complicated thing. And by and large, it's kind of close enough for government work, right? You might want more. You might want to know like what's going to happen to this thing as we go into a recession, as we go into a boom. And people certainly do study the heck out of the consumption function. And it is more complicated than this. But if you're not like into that kind of thing, you're not far off with a linear thing like this, right? We can certainly do better, but we are not doing as bad as you would think. Like normally you write down a simple linear thing, you figure you're way, way the heck off, but you know, you're thinking about something, right? And so hopefully it's good enough. Here, yeah, obviously you're off. The real world isn't linear, but it's not as bad as you would think. But not as bad as most of these things are when we assume a simple function. Okay. So we're going to have planned aggregate expenditure as a whole, right? So this is, remember, planned aggregate expenditure is C plus planned investment plus government spending plus net exports. Let's add all those things up. We've made a story about consumption, right? This little consumption function is a story. And the story is, I look at my income and I spend accordingly. When I have more income, I spend more. How much more? The marginal propensity to consume more, right? So that's our story. We did it in a graph. We have the equation. I just told you the story. It's not deep, but there it is. It's a story, right? So we have the 3 ways to think about it. And in principle, the other bits have the same thing. So we're going to think about them as, again, autonomous and induced. So investment could have an autonomous and induced part. Government spending could have an autonomous and induced part, and so on. So we can think about all the bits that don't vary with income as autonomous expenditure as a whole, not just autonomous consumption, but also the autonomous investment, the autonomous government spending, the autonomous net exports. All of those things added up together, it's going to be our autonomous spending. And because we're doing this for our first pass, we're not going to have any story for all of those. So everything else is going to be autonomous. It's just going to be like fallen from God. God gives us investment, God gives us government spending, and we just deal with it. So they're just going to be fixed numbers. They're all going to be autonomous in our first pass. Okay. And of course, the part that depends on income is going to be the induced expenditure. Okay. So here we go. Here's our planned aggregate expenditure. Right? So here we have C plus I plus G plus net exports. C is autonomous spending plus induced spending, marginal propensity to consume times the amount of income. Right? And so clearly that's our only induced bit. So the marginal propensity to consume must be 0.8 in this particular example. Right? So if we find €1, we spend 80 cents, we save 20 cents. Right? And then we add in autonomous consumption, investment, government spending, net exports, and all of that adds up to 950, and I graphed it. Okay? So we have if, here I wrote output, but again, we are thinking income here. Right? Why? We call it output, we call it income, call it expenditure. Here we are thinking about it as income. Okay? And here we have expenditure. Now, you will recall that Barbie has multiple facets. She's got multiple aspects to her nature. And here we have taken GDP, which also has the multiple aspects, and we have divided them up. We have, on the y-axis, we have put the aspect of spending, aspect of GDP, of expenditure. And then we've put the other two down here. So you can think about this as output, you can think about this as income, and we have sort of pulled off the expenditure aspect here in a goofy kind of way that's sort of unnatural since we think that they're all the same. It's natural if you don't think they're all the same, but it's a little unnatural if you've grasped the sandwich theorem, right? It's because they got to be the same. We've divided them up, right? So here we have the Barbie astronaut, here we have the Barbie fashion model and deep sea diver. They're all still Barbie, as we know. And according to I forget her name. The woman who sang Jolene. Dolly Parton. Dolly Parton. She's a backwoods Barbie, so she's one of the aspects as well. So just divide it up that way as well. Okay. So we got our Keynesian model. And that's our whole story. Like, this is everything that's going into this story is basically this consumption function. There's basically nothing else so far. And the important thing here is that as you get richer, you spend more, but not as much as you got richer. Okay, that's the idea. Okay. Now we need to say something about what's going to happen, right? So we need some kind of notion of equilibrium. And normally, like when you took microeconomics, what we would have is we would have like characters in a story. We would have Little Red Riding Hood and we'd have the wolf, and we would see how they interacted. And so we had the shoe salesman and we had the shoe buyers, and then we would see how they interacted. And the shoe salesman got a supply curve and the shoe buyers got a demand curve, and we interacted them by putting them together. And that was our equilibrium, right? That shoe buyers doing the best they can, shoe salesmen doing the best we can. Here's the prices and number of shoes that we get. Right? That was our story. Now, here, we don't have that. This is one of the few economic models where we don't really have a line representing two different decision makers. Normally, you would have a line representing one set of decision makers, a line representing another set of decision makers, and you'd interact them. Okay? Here, our line is going to be representing the oneness of Barbie. It's going to be putting all the aspects of this person, of this sandwich together, so that the amount that people are spending is equal to their income. And so our story here is that when we are spending, we are not worried about the macroeconomy. The macroeconomy can go F itself. We are just doing the best we can with the money we got. right? And so that's why when we drew this consumption function, we didn't talk about the macroeconomy really. We just said, what is my income? Here's how much I'm going to spend. Okay? For most of us, not Bill Gates, but for most of the rest of us, that seems reasonable, right? That we don't really worry about the rest of the economy. We just do the best we can given the goofy world we live in. Okay? So that was our story. But we know as macroeconomists that that income didn't just fall from the sky. That income is because somebody is producing that stuff. And in our story, they are producing because someone is buying. Right? We have our barber shop. Our barber is just waiting for a customer to come in. If the customer comes in, he produces a haircut. If the customer doesn't come in, he doesn't produce a haircut. Right? And so all the income he gets has to be from cutting hair. Right? And so we know as macroeconomists that not for an individual, but for the economy as a whole, income and expenditure have to be the same. This income didn't come from anywhere. It came because we were producing something. We were producing these haircuts. And so for equilibrium, we want to bring those aspects together. On the graph, we've kind of arbitrarily divided it. Here we've got income and the amount of stuff produced. And here we've got expenditure. But we want to bring them together because we know that they have to be the same. Now this feels a little goofy that we're separating them and bringing them back together. And indeed it kind of is. But there's a reason for it. And the reason is because we as macroeconomists know that they have to be the same, but individuals, when they're making their decisions, do not, right? And in fact, they don't for an individual. And so we separated them out because only individuals were looking at particular things when they were making their decision, right? They were looking at their income to decide how much to spend. And so we wanted to separate those two out because they, in their heads, didn't think my income and my expenditure have to be the same. None of us think that way, right? Because it's not true for us. It's true for the economy as a whole. Okay? So we divided them up for that reason. But now, as macroeconomists, we want to put them together. And we know that income and expenditure has to be the same. And the income comes because you produce something, so it has to be equal to output. And so that's what we're going to add in, our equilibrium condition. Short-run equilibrium output is going to be, definition. It is going to be what? It's going to be all the places where y is equal to planned aggregate expenditure. Right? So planned aggregate expenditure determines how much we're buying, which determines how many haircuts get made, which determines that's the number of haircuts, that's y, the output nature of y. But it's also the income that people get. Right? So income and output have to be equal to expenditure for the economy as a whole. And that's what this line is representing, where both of those things are true at the same time. Okay. Now, you'll see there's a little 45-degree line here, right? A little 45-degree, because we're putting down all the points on this graph where this identity is true, where output and income are the same thing. Income and expenditure are the same thing. Because the only way you get income is because someone bought something at your shop. Right? So that just comes out to 45 degrees. So there's nothing. We're not going to do trigonometry with this. We're not going to say, okay, 45 degrees, the tangent of 45. We're not going to do that. It's just a way to think about it. Our story is y is equal to planned aggregate expenditure, and that, of course, comes out to 45 degrees. But whichever way is easier for you, but it's not a trigonometric sort of degree thing. It's just one of those facts. Okay? So that's where equilibrium is going to be, where output and expenditure are the same, right? Because the reason we produce something in this story is because someone is buying it. Okay? We wait for them to come, and then we say. So now we just need to put these two things together. This macroeconomic phenomenon that output, expenditure, and income all have to be the same, sandwich thing. Put that together with how much do people actually want to spend, and that's going to give us equilibrium. Okay? So I'm going to do it graphically. I'm going to do it mathematically. So let's take a look at our math here. I call it E. Okay. So let's do it mathematically. And you have the slides. Let me get myself in frame here. And then I'll take you through the math. Because math is so much easier to follow if someone does it rather than, Okay. That's fun. Okay. For better or worse, there's no camera. Okay, so what's the deal here? So what do we have? We have y is equal to planned aggregate expenditure, right? That's our equilibrium condition. That is, how much stuff we produce is equal to the amount that people spend, because we got this barbershop metaphor going on, right? And how much do people spend? Well, they spend C plus IP plus G plus net exports, right? And the other thing we know is we know that C is equal to C bar plus little c y minus t. That's our consumption function. Right? These are the things we know. Right? And so what we can do is we can plug C in for C, because it's the same thing. This is, in general, y is equal to C plus I plus G plus net exports. And now we have a particular story about where consumption comes from. We need to plug that in. Right? So I can write this whole thing as y is equal to C bar plus little c times y minus t plus IP plus G plus net exports. Okay? And we don't have a story for investment. We don't have a story for government spending. We don't have a story for foreigners. So all of those are just numbers that were given to us by God. Okay? We didn't explain them. We don't have a story for them. These are going to be unexplained by the model. Okay? We can make the model better. We can make the model fancier and make these things part of the story, but we haven't done yet. So these are all going to be autonomous. And so what I'm going to do is I'm going to write this thing, and I'm going to multiply out this stuff to separate out the autonomous bits from the induced bits, the parts that depend on y, the parts that don't depend on y. And you can see that there's only one bit here that depends on y. And so I get y is equal to, let me just multiply it out. Cy plus C bar minus CT plus IP plus G plus net exports. Just multiplying this bit out here, I did the little c times y first, then I got my C bar from here, and my little C times minus t here, right? And then I'm going to take all of this stuff, and because that is in the model, all unexplained. Right? This is stuff that we're not really explaining with this model. So I'm going to just lump it all together as exogenous spending. There's the exogenous consumption. There's the fact that we have to pay our taxes. There's the exogenous investment. There's the exogenous government spending. There's the exogenous net exports. All of this is stuff that we don't even hope to explain with this story, right? It's just given to us. And so I'm going to take all of that stuff, and I'm going to call it E. Just because one letter is so easy to carry around, where a whole bunch of letters is just a nightmare to write. Okay? And then a whole bunch of letters makes people lose the forest for the trees and not see what's going on. Whereas one letter is just, So I'm just naming it. I called it E, Edward. This is Edward. So y is equal to Cy plus Edward. Okay? We just gave it a name. Okay? So y is equal to induced expenditure plus exogenous expenditure, autonomous expenditure. Just like we said, right? And induced expenditure, in particular, we know what it is. It's little c, marginal propensity to consume, times y. Okay. And now we want to solve for y. And you'll notice that in this thing, on the left-hand side, we have output, and we've got income. And on the right-hand side, this was, not income, expenditure. And on this side, we have income. Right? We have the two different aspects of GDP. Two different ways of thinking about the sandwich. We got the sandwich itself, and we got the income that people get from selling the sandwich. But of course, we know they have to be the same thing, which is why we gave them the same letter. And so now, okay, but when we wrote this down, we had the two different notions of how to think about them. But now, we can forget about that. Now we can just go back and forth between them, treat them like they're identical, because they have to be for the economy as a whole. Right? So this whole thing is just y. It's just an ordinary equation, and we just have to solve to find out what y is. Okay? So we got one equation. We've got one thing that we don't know, which is y, and so we can solve this. Right? You will notice, as an aside, that one of the things that we're getting because we are doing this in math is the math is going to tell us how much we can learn from the model, right? Because we put down one story which was this story about how people consume. It's a goofy little obvious story, which means we have one story. That means one equation. So we can, if you have one equation, you can at most get one thing out of it, right? You can explain one thing with one story. If you wanted to explain two things, like suppose you wanted to explain, output and the interest rate. Well, if you wanted to explain two things, you would need to put more into your story. Because we only have one equation, we can only solve for one unknown. That is a basic mathematical fact. And so the putting it into a mathematical form, our story, really tells us, among other things, how much we can learn from this model. And one thing, tops, right, is what we can learn. We cannot learn two things from this model. Like abstractly, we can learn two things, but we can't solve for two variables in this model. Because we only have one equation, we've only put in that much information. We cannot get more information out than we put in. Right, so we put in one story, we can get one equilibrium value out. In this case, it's not a problem, that's all we're looking for, but it's worth noting that we got one equation, we've got one unknown, we could solve that. If we had one equation and two unknowns, we could not. We would have to put more into our story. Okay. So let me do another page here, because actually people do get lost at this stage. So we got y is equal to cy plus e. That's just copied from the previous page. Now I got y on both sides, and so I'm going to subtract cy from both sides. And the reason I'm doing this is I just want to get, I'm trying to solve for y. This is the thing I don't know. What is equilibrium output? What is GDP in this economy? And so I'm going to take all of that and try to put it on one side and put everything else on the other side. Right? So I get y minus cy is equal to e. I just subtracted cy from both sides. Okay? And then I notice, because I'm super clever, that we got y here and we got y there. We got two y's. Everything on the left-hand side is multiplied by y. And I say, aha, I can factor that. And so I will. And so I just say everything's multiplied by y, so I can write this as y times 1 minus c, like so. Okay. And that has to equal e. Okay. I can do that. That's fine. That's kosher. And then, because I'm dealing with math, I can do any legal thing with math that I want. I can do anything I want, as long as it's legal, to both sides. What I am going to do to both sides is divide by 1 minus c. Right? Now, that may or may not be legal. It depends on what c is. If c was 1, I can't divide both sides by 0. Right? Which is telling me that my model is going to give me no information, is going to be useless and goofy and stupid if c is equal to 1. It's not going to give me anything then. Okay? But if c is less than 1, between 0 and 1, like I assumed, then it's going to be fine. And that, of course, is really why I assumed it. Because I solved this out and I said, oh my God, c can't be 1. I can't do the math. Right? And so I said, let me go back and assume that and make sure that everything's kosher. And, so divide by 1 minus c, we get y is equal to e divided by 1 minus c. Or y is equal to 1 over 1 minus c times e. Okay? Obviously, they're the same thing, right? Hopefully, that's obvious. Okay? What does that tell us? What's that good for? So that's how to do it. Let's, okay. Do we want to talk about it here? Oh. Yeah. Yeah, so that's just what we've got. Okay, that's not helpful. That may be helpful. Here we got this thing. Let me talk about it just briefly. We'll come back and we'll do it again in a different way. But we can see autonomous consumption is here, right? It's multiplied by this thing. This thing is going to be something that we're going to call the multiplier, the thing that multiplies autonomous consumption. Technically, a lot of times we'll call it the government spending multiplier, the autonomous spending multiplier, or just the multiplier. Typically just the multiplier. And it is saying if autonomous spending changes, this is how much y is going to change. Right? So you can imagine that autonomous spending goes up. Say autonomous spending goes up by 10 million euros. Right? So 10 goes up by 10. Well, why could that be? It could be because house prices go up and we all feel rich, and so we start buying other things. It could be because we're very optimistic about the future. Life looks good, and so we start buying things. Right? So if autonomous spending goes up, output is going to not go up by the amount. It's not going to go up by 10. It's going to go up by 10 times this multiplier. 10, in this particular case, 10 times 1 over 1 minus c. Right? So what is this? What kind of numbers do we have here? Like in reality, well, we're kind of thinking, C is kind of maybe 0.95 is a reasonable number to think that this marginal propensity to consume is, right? And so that means 1 minus C is more or less equal to 0.05, right? And so 1 over 1 minus C is more or less equal to 20. So if autonomous expenditure goes up by 10 million euros, output goes up by 20 times that, 200 million euros. Okay? And this is why this is a big deal, that small changes in autonomous expenditure can have really large changes on output as a whole. Okay? And so some of those things are things that are just going to happen to us. People get optimistic. People get pessimistic. Foreigners stop buying our stuff, a mad cow or whatnot, right? And they just stop buying our stuff. The effect on our economy is going to be much bigger than it looks. Okay? For those of you who are sports fans, whenever they do try to get the people to pay for a stadium, they'll come along and they'll say, well, our stadium is going to bring in, 50 million, but multiplier. So 50 times the 20, and that's how much the stadium is worth to society as a whole. To us, it's only worth 50 million, but to society as a whole, it's worth 50 million times 20, so €1 billion, right? Because of this. Okay, so next time we'll do the story for why this is, because that's the crucial bit, but I'll let you go.